Hi again and welcome to this summary of organic compounds, and what I want to do in this lesson is summarize how we were naming organic compounds. And to do that, I'm going to start from the beginning with alkanes and how we named alkanes. Okay, so an alkane was named first of all by recognizing the number of carbons, and then for that number of carbons, one would be meth, two would be eth, three would be prop, four would be bute, five would be pent, six would be hexa, seven would be hepta, and 8 would be octa. I'm only going to go up to 8. 8 would be octa. Okay, and then actually oct. Okay, but then we would have the suffix ane. Okay, that is how we would name alkanes. I'm not going to look at examples. I'm simply going to summarize it here. Okay, the next one we looked at were alkenes. Alkenes worked exactly the same. We would count the number of carbons, but what was the difference between alkanes and alkenes? Well, an alkane had a single carbon bond, while alkenes have double carbon bonds. Okay, at least one carbon is double bonded to another carbon, and it works exactly the same. We will use one of these, and I must just correct these hex. Okay, it would end on an ene. Okay, an alkene has the suffix ene. Then the alkynes, we had alkynes next. The alkynes had, how we would know it's an alkyne is by looking for a carbon triple bonded to another carbon. Okay, in this case we will have a YNE. The next one that we looked at was haloalkanes. Okay, so our haloalkanes. Okay, and you get haloalkenes, haloalkynes as well. We looked at haloalkanes. That is where we have one carbon that has at least one bond with a halogen. This is a halogen group 7, and it worked exactly the same, but this one had a prefix. So we had a prefix, and the prefix was either fluoro, chloro, iodo, actually first bromo, or iodo, depending on what the halogen is. We get fluorine, chlorine, bromine, and iodine are the halogens that we worked with. Okay, those were the haloalkanes. After the haloalkanes, we looked at alcohols. Okay, so we looked at alcohol. Okay, in an alcohol, we have a carbon that is bonded to an oxygen bonded to a hydrogen. In other words, a hydroxyl group. Okay, a hydroxyl ion, a carbon bonded to a hydroxyl ion is an alcohol. Okay, it is important that the rest of these are all either bonded to carbon. It can't be another oxygen. That would be the carboxyl derivatives. Okay, so an alcohol had a suffix. The suffix for an alcohol was OL. So it's either it would be at the end of the AN, EN, or IN. So it would be methanol, ethanol, propanol. Okay, and then after that we did the carboxyl derivatives. Let me write them down. Okay, carboxyl itself was not a name. Okay, but the carboxyl is when I have a carbon double bonded to and oxygen, and now I've got some choices. I can either have aldehyde. An aldehyde has a carbon double bonded to an oxygen, single bonded to a hydrogen, one hydrogen, and then the rest of it can be a few more hydrocarbons. Okay, so some sort of alkane or alkene or alkyne structure, okay, would be in here, and this would be an aldehyde, and the way that we would write that is either AN, EN, YN, depending on this structure here, but instead of ending on an E, it would end on an al. Okay, al. So in other words, carbonyl, not carbonyl, methanol, ethanol, propanol. Okay, and where does that al come from, or how can you remember it? It is from aldehyde. Okay, the next one that we looked at was the ketones. The ketones. A ketone was similar to an aldehyde, but it's almost a more complex aldehyde. It is a double bond carbon double bonded to oxygen, but both of these other bonds were substituent groups. Okay, in other words, the difference between an aldehyde and a ketone is that an aldehyde had the double bond on the first or last carbon, however you want to look at it, but the aldehyde would be on there, and then the ketone has the carboxyl group on one of the carbons inside the chain, not on the end. Okay, and the way that this one will be named is ONE. Okay, ONE. So in other words, methanone, ethanone, propanone. And where does the ONE come from? There, from ketone. That's how you're going to remember it. The same with ol. I didn't mention that, but the same with ol is alcohol. Okay, and the ane, ene, exactly the same there as well. So the next one we looked at was the carboxylic acid. Carboxylic acids. Carboxylic acids. The carboxylic acid was a carbon double bonded to an oxygen, bonded to a substituent group, but on the other side, instead of bonding to another carbon or hydrogen, it is bonded to an oxygen and a hydrogen. In other words, similar to an alcohol, but this is not an alcohol. This is a carboxylic acid, and the carboxylic acid ends on the words oic acid. So in other words, it is methanoic acid, ethanoic acid, propanoic acid, octanoic acid. Would be 8 carbons, double bonded oxygen, and a singly bonded to the hydroxyl ion. Okay, that's carboxylic acid. And the last one we looked at was the esters. The ester, esters. Ester was a carbon double bonded to an oxygen, bonded to a substituent, but on the other bond, yes, there's an oxygen similar to carboxylic acid, but then connected to a substituent again. Okay, so what's the difference between these two? This one has a single chain of carboxylic acid has a single chain of carbons, and on the end we have COOH. Okay, this one has 2 chains of carbons, okay, broken up by the 2 O's, broken up by the 2 O's. So we have, this one had a substituent, okay, this one has and I should name this one different, has a substituent carbon double bonded to an oxygen, single bonded to another oxygen, and then another substituent. So we have this coup in the middle, and the way this one is named is slightly more complex because this is not just a single chain. We will have an alkyl. This is an alkyl group, so we'll have an alkyl name, okay, and then we will have an alkanoate. alkanoate name. Okay, so I forgot my L there, alkanoate. So the alkane refers to the name we would use here. So and the alkyl would also refer to a group, like a branching of whatever this branch represents. Does it represent a methyl? That is a branch with 1 carbon, an ethyl, a branch with 2 carbons, a propyl, branch with 3 carbons. So basically what I am saying is that now the one that I haven't yet looked at is called the let's do this, the Alkyl Group. Alkyl Group, even though I have just mentioned it, the Alkyl Group is when I have simply a substituent. So it is a carbon bonded to an already bonded to a chain of carbons. So here a chain of carbons. So here, let's do it like this. Here I've got my chain of carbons, okay, and then bonded to that I've got my alkyl. So an alkyl, I should have mentioned it earlier, but there's a reason why I put it way down here at the bottom. Okay, an alkyl is just named with a YL suffix. Okay, a YL suffix, and it still uses the same as these, but we write that part as a first part in the name. So now we come down to numbering the carbon chain, because in order to actually write down the name, we need to say where is this suffix. So we need to number the carbon chain. Now, numbering a carbon chain, the first thing we would do is identify the longest chain. Okay, as soon as I identify the longest chain, that would determine what I use. After I know what prefix I'm going to use, the rest of the carbon chains are then alkyl groups. Okay, now in order to write down, let's say, an alcohol, the OL, I need to indicate in front of here which carbon it the hydroxy ion is on in the chain. Now I need to number that carbon chain. But what if my carbon chain, if this hydroxy ion is not on one of the ends? Okay, so usually I would start with my functional group numbering from there, but what if it's someplace inside? Let me give an example, even though I don't want to give examples for the sake. Okay, but for example here, and I've got my hydroxy ion right there. How would I number? Now we would give priority so that the functional group has the lowest carbon number possible, so it would number from the left to the right. But now the problem is, what if I had another, I don't know if this naturally occurs, but what if I had another functional group there? Yeah, well, in this case I would need to know which one will have priority, and I just want to show you what will we give priority. The first two that will get priority would be the carboxylic acid and the esters. I would give them the highest priority, and if they were both carboxylic acid and ester functional groups in the same chain, I would give carboxylic acid, then ester. The next one would be the aldehydes and ketones. They would have second priority. I would give aldehyde higher priority over ketones. Okay, then I would look at the alcohols. Okay, alcohols would have third priority. Now here is where it becomes a little bit confusing, because we've been working backwards. However, when it comes to the double and triple bonds, we would give them a higher priority. They would come in fourth place. Okay, fourth place, obviously giving alkenes the highest priority above alkynes, and then only will we have the haloalkanes. Okay, so that the last one to get any priority would be the alkyl groups. Okay, so alkyl groups would have the last one to have priority. So if I had a branch on top of any of these, I would number it according to any of these first, and then consider the branch. The only additional thing I want to mention is, let's say we have any of these functional groups in more than one of them in a chain, then we would use a suffix in front of a prefix in front of the suffix. So here's the suffix. We will use something in front of it, like diene or triene or tetraol. Okay, and that depends on how many of those there are in the functional group. So we would also use a prefix to the suffix of di if there's 2. 3 would be tri if there are 3 of those functional groups of the same functional group, of course. 4 would be tetra, and you won't get more than this for this course, so let's stop it there. So let me just do 2 examples to illustrate all of this together. So in this example, I have a carbon chain of 1, 2, 3, 4, 5 carbons. So I know I'm going to work with pent. Okay, and I see on this this pent I've got a triple bond, and I've got a chlorine. Okay, triple bond and a chlorine, which one would get preference? Because I'll either start numbering from here or from there. Okay, so if I go and look, the haloalkanes have second to last priority. The only thing that has a lower priority than the haloalkanes are the alkyl groups, in other words, branching. Okay, and in this haloalkane, so I would give the alkyne the highest priority. So we'll start numbering from this side: 1, 2, 3, 4, 5. Okay, so I would have a 5 chloro. Okay, because the halides get the O-wo prefix, and then pent 1 ine. Okay, and it would not be necessary to write that one, but I'm going to include it as well. Okay, one more example. Okay, so in this example we have 3 carbons, so I'm working with prop. Okay, I see I'm working with an alkene, so it's propene, and then I have an alcohol, so it's propanol. Okay, and now I just need to decide which one gets preference. Okay, and let me actually rewrite this. This is propanol. Okay, I need to write the numbers on this carbon chain where they should go. Okay, so will I number from this side or from that side? If I go and have a look, my alcohol gets prominence over my alkenes, so I'll number from that side. So it would be propene 1 all, and the ene is on 3. And if there were any other carbon chains, so let's say this was carbon, it would be an alkyl group. Okay, and this one would then be numbered on 2. We would have a ethyl, 2 ethyl prop 3 N1 all. There we go. I hope this was a helpful summary for you of all the organic chemistry naming of the compounds, and hopefully we can go on to the next topic where we'll look at a summary of the properties. So I'll